Hi, this is Sai Potana, founder at Embedded Systems AI LLC. In this video, I'm going to talk about scalability and partitioning patterns. This pattern answers a single question. How do you keep up when the workload grows? Scalability is the patterns layer that answers that question. In section 1, we're going to talk about horizontal scaling, the foundational pattern of the cloud era. Instead of buying a bigger machine, add more machines. The benefits are clean. Throughput grows roughly linearly, costs stay reasonable with commodity hardware, availability improves because no single machine is critical, and growth is incremental. The disadvantages are more nodes to manage, network overhead grows, state management becomes complex, and scaling is rarely perfectly linear. Horizontal scaling is the default for any modern system, but it's not free. Section 2 talks about sharding. If horizontal scaling is adding more servers, sharding is about splitting the data so each server only handles part of it. This is what makes truly massive databases possible. The strengths enables huge data storage, fast queries within a shard, parallelism across shards. The weaknesses, cross-shard queries are genuinely hard, rebalancing is operationally painful, and hard shards are a constant production risk. Use this pattern when there is actually scale to justify, not before. Section 3 talks about consistent hashing, one of the most elegant ideas in distributed systems. With a naive hash partitioning, adding a node forces almost every key to move. Consistent hashing places keys and nodes on a virtual ring. Adding a node only moves the keys between the new node and its predecessor. This is how DynamoDB, Cassandra, and modern CDNs scale dynamically. The catch is imperfect balance without virtual nodes. Section 4 talks about replication for read scaling. Most workloads are 80 to 90% reads. Replicate your data and you can serve n times the read traffic without touching the write path. The benefits: higher throughput, better availability, better geo-distribution. The costs are equally familiar: write amplification, replica lag, storage overhead, and consistency management. The next section is about partitioning by range. Split data into ordered ranges, keys 1 to 1000, 1000 to 2000, and so on. This pattern is excellent for time series and log data because range queries are fast. The fatal weakness: skew. If you partition by timestamp, the newest partition gets all the writes, and a hotspot by design. Part 1 was about foundations of scalability. Part 2 is the advanced layer, the patterns you reach out for when basics aren't enough. Section 7 talks about virtual nodes, the solution to consistent hashing's imperfect balance problem. Instead of placing each physical node at one point on the ring, place it on many, typically 100 to 200 virtual positions. Each physical node owns the union of its virtual slices. Load distribution improves dramatically. Node churn handles gracefully because losing one physical node spreads its nodes across many survivors, and nodes can be weighted by capacity. Cassandra and DynamoDB use this by default. Section 8 is about multi-tenancy isolation, the pattern for SaaS and platforms serving multiple customers. Instead of placing all tenants in one shared table, give each tenant its own partition. Strong tenant isolation, noisy neighbor protection, clear compliance boundaries. The cost is lower resource utilization because each tenant has dedicated capacity even when idle. Most mature SaaS platforms pool small tenants and isolate the large ones. Section 9 is about hierarchical partitioning. When one level isn't enough, partition at multiple levels. Region first, then shard, then segment. This is how Spanner and CockroachDB span the planet. The benefits include massive scalability, locality and low latency, fault isolation at multiple levels, support for data sovereignty laws like GDPR. The costs scale with complexity. Design and operations are genuinely hard, global rebalancing is difficult, and there are simply more moving parts to fail. Section 10 is about elastic partitions. Treat partition layout itself as dynamic. When a partition gets hot, split it automatically. When partitions get cold, merge them back. This is how DynamoDB autoscales under the hood, and how CockroachDB does automatic range splitting. The system adapts to load without manual intervention. The risk is crashing. It splits and merges in a feedback loop if thresholds aren't tuned carefully. Section 12 is about data locality awareness pattern. Place data close to where it is accessed. US users hit the US data center. EU users hit the EU data center. CDNs are the canonical example. Benefits are immediate. Lower latency, reduced cross-region traffic, compliance with data residency laws. The costs, complex routing logic, expensive cross-region sync, harder failover. Retrofitting locality into a single region system is one of the most painful migrations in the distributed systems. To sum it up, the patterns in this video are the ones that separate engineers who can speak superficially about scaling from engineers who design the systems other engineers later study. Most know horizontal scaling and sharding. The ones who speak fluently about virtual nodes, elastic partitions, and hierarchical geo-distribution and explain when each is worth its operational cost are operating at a different level. This domain rewards depth. Thank you.